Hi, in this video we will talk about distributed recovery in MySQL group replication. What is distributed recovery? Why do we need a distributed recovery and how we can do the distributed recovery? Say for example, you have a 3-member group in a group replication. You have a 3-member group. And imagine it is in a multi-primary mode. You can perform DML on each one of them. Each DML gets a GTID, Global Transaction Identifier, assigned, and the transaction gets propagated to the other members as well. That's how the data is made consistent across the group. So you connect to this machine and you perform a DML, it gets a GTID, and the GTID gets propagated across the members. Imagine you're doing some transactions. So GTID 1, 2, 3, 4, and then 10, and then 100. We have done 100 transactions and then 125 transactions. Here also the same. These things get propagated here. So 1, 2, 3, 4, and then 10, and then 100, and then 125. So this member is also up to the mark. Here also the transactions get propagated here also 1, 2, 3, 4 GTIDs, and then 10 got applied, and then after 100, you just imagine this node went down. This node is no longer accessible to the group. Either it could be voluntarily for some sort of maintenance you brought the member down, or it could be involuntarily due to the software crash or a server crash or the network crash, whatever it is. So and this member you just got the transactions or GTID is still 100. We know from the group replication, as long as the majority of the members are available, the database is accessible for both read and writes. So here you have the majority as 2 members. Out of 3 you have the 2 members available. That's why it was able to continue and it was able to generate further transactions. The clients could connect and do further transactions which generated further changes or GTIDs, right? From 100 to 125. Now this member is not having those transactions, or these transactions got missed on this member. So after some time, imagine if this member comes back, you can still connect to this member and read the data, but the data would be stale. The data would be as of this transaction or GTID 100. The data is stale. So it is our responsibility to bring up this member up to the mark. So the missing transactions from 100 to 125, the missing transactions, we need to get them applied on this member. So that is what is called as a distributed recovery. So the missing transactions that happened on the group while this member is down, the transactions that happen on the group, we need to get those things applied. We need to have those transactions applied on this member once it is back, so that it is brought up to the mark and is a part of the group again. So the process is called distributed recovery. And this video is to see the steps how we can do that. But before that, I wanted to share few details that will help us to understand this thing better. Okay, imagine we have 3-member group replication. It could be either a multi-primary or the single primary. And imagine a user connects to the member and does a DML. The session performs a transaction and does a DML. A GTID is generated. So this member, it prepares the write set and it propagates the write set to the other members. It prepares the write set in the memory and it propagates the write set to the other members. So in the memory, the other members checks if there are any conflicting transactions with this transaction. If there are any conflicting transactions, then it has to take care of resolving the conflict we saw in the previous video. If there are no conflicting transactions on the other members with this transaction, then the group is fine. Then the group provides consensus saying the group members are okay with this transaction. Because we know the commit is not a unilateral decision. Not one member is authorized to deal with the commit. It needs to get the consensus from the group members. So once it gets the consensus that there are no issues with this transaction and it can be committed, it is written into the binary log. The transaction is written into the binary log and is committed. The same way to the other members, since they need to be consistent with this change, it is passed via the group replication to the other members. There it is written to the relay log file. There the change is written into the relay log file first. And as process of applying, it gets written to the DB files and also it gets written to the binary log files. Then the change is committed here. Same way here, from the relay log, it gets applied to the database files and also it's written to the binary logs. Then the change is committed. The reason to write into the binary log files is in case if any of the member requires those transactions later, it can extract those transactions and apply on. Now, in our case, one of the member is not available for some time. This member was not available for some time, but the group progressed from 100 GTID to 125. So it is missing some transactions. Since all these transactions are written into the binary log files on all the members, the transactions are written into the binary log files. This member, once it gets connected to the group, it compares its GTID. Okay, I have got all the transactions till GTID 100 and I am missing transactions from 100 to 125 which are available with the other members. So this member connects with the other members and requests those transactions. The other members are having those transactions on its binary logs. 100, 101, 102, all these transactions are available on its binary logs. So this member can connect as a client to one of the existing members. So this thing, when it comes back, it can connect as a client to one of the existing members. It could connect to any of them as a client and request the missing transactions. Once it gets those transactions, it can apply them to the database and bring this member up to the GTID 125. So this is the distributed recovery. So this is the little bit background about that. And this diagram shows the same thing. When a session connects to any of the member 1, member 2, member 3, it could connect to any of the member. It executes a transaction. The transaction gets a GTID. This member prepares the write set and passes on the write set to the other members. There the other members certify, okay, I don't have any conflicting transaction and this transaction is fine. We are good with this transaction. Then once the transaction is certified, wherever the session is connecting, right, on that member, it gets written to the binary log file. It gets applied to the database and the user gets a commit as soon as the transaction is written to the binary log file. The other members, this transaction is propagated through the group replication. We saw that right here. Through the group replication method, the transaction is propagated. So once the transaction is propagated, it gets written into the relay log file. It gets written into the relay log file. And it is applied to the database and also written into the binary logs, and then it is committed, the change is committed. The point is it gets written into the binary log. Once it is there in the binary log, if any of the member is not part of a group replication for some time, and if it tries to come back and becomes part of the group replication, that member, the joining member, the terminology is this member, once it is trying to join, it is called as a joining member. And one of these two could become as a donors because they are giving their transactions from 100 to 125. In this case, from 100 to 125 GTIDs, they are giving it. So one of them will become the donors and this member will become the joining member. This joining member can get those missing GTIDs from the existing members' binary logs. And this member, while joining, it acts as a client, and one of these two would become as a server. Also, we have seen this table, group replication members, which provides the details of the members and their states and other stuff. And this table helps us to see the statistics till what GTIDs are applied, how many transactions happened from this local node, how many transactions happened from the remote node, how many got certified, and how many are pending to be certified, how many conflicts did we got, how many rollbacks happened, all the details we can get from this view, group replication member stats. So let me show that. Okay, so this is the thing, replication group member stats. So this is the channel name. And view ID, we know that view ID tells us what are the online members of a group. If the number of members changes, or if an existing member leaves, or if one member tries to join, this view ID changes, and that detail gets propagated across the group. We even know each member will have its UUID. So we can see each member is having its own UUID. And count transactions in queue, how many are yet to be certified, how many transactions it checked. See this thing, it checked 3000 transactions. These two members checked 3000 transactions. And how many conflicts detected? No conflicts. And count transaction in the last thing, how many transactions did it validated? Transaction committed all members. If you see this thing, each member of the group can generate a transaction, right? So each member will be assigned a block of GTIDs. So one of this member is assigned from 1, and the other member is assigned from it is 10 lakhs or 1 million, and from 2 million. So I will show this again. So each member will be assigned a GTID block. So if you try to connect from one member and do a transaction, that member's GTID will be increasing. So we can see the transaction committed on all members. And the last conflict-free transaction, all of them show that 1071 was the last conflicting transaction. And how many are there in the applier queue yet to be applied? It says like, this particular member has got 2000 odd transactions from the remote, from the other members. On this member, there were 1000 transactions, 1000 odd transactions initiated from this member. So it shows all of the details which are helpful for us, and how many transactions performed on this got rolled back. In case of conflict, it has to roll back, right? So only one of the conflicting transaction would go through and the other one would be rolling back. So it would show all the required details from this view. So I wanted to show that before we do this activity. Okay, if you have seen my previous video, we know that we have a 3-member group. MySQL 1 is one server, MySQL 2 is another server, and MySQL 3 is another server. We'll try to connect each one of them and do some sample transactions and see some other details. So for that, I already have a database, a testDB, and in that database, I have a users table. So I have a procedure to insert some dummy data into that users table. So this is my MySQL 1. If you see here in the testDB, I have 3002 records in this users table on the MySQL 1 member, and on the MySQL 2 member also I have tested database. In that tested database, I have a users table where I have 3002 records. The same thing with the MySQL 3 member also. I have a table, and same 3002 records are there. We will try to insert some dummy data from one of the member and see. So I am trying to insert 1000 records and do 1000 transactions roughly. And I am doing this from member 1 and from member 3, or I want to see the contents of this table also while I do that. Okay, now you see here on this member the details you can check. So we have done some 1000 transactions and inserted 1000 records. Let's see that. So 4002 records now. The same thing from member 2, MySQL 2. The same thing from MySQL 3 or member 3. If you check these details, transactions checked, it increased. And let's also check the GTID across the members. So it is for one of the member, the transaction count is 2071, and for the other member, it has got all the transactions till 2136, and for the other member, 19 transactions. So let's see if this thing is consistent across. Okay. So if you see this thing, let me copy it from MySQL 1. That will be easy. This is the detail from MySQL 1. And this is the detail from MySQL 3. Let's copy that from MySQL 2 as well. So if you see this thing, each one of the member has got all the transactions from one of the member from GTID 1 to 2071. And from the other member, it has got all the transactions from 1,000,001 to 1,021,36. The same thing for the third member also. So all of them has got all the transactions that are applied. So let's try to apply some other transactions on member 2 and member 3 as well. We don't need to apply them in the order. From member 3, I am doing some 100 transactions. And from member 2, let me do 200 transactions. So now let's check the GTID executed. If you see this thing, 2136, it jumped to 2236. And this thing for the other member also, it was 19, it jumped up to 219. So that means this block of GTID is representing MySQL 2. And if we compare them, the GTIDs would be same, 2236 and 219, 2071. So the GTIDs would be the same. This is the way how we check that the transactions across the group are consistent. So let's try to get into the real activity where we will bring down one of the member and try to do some transactions on the remaining two members. So for that, let me stop the group replication. Imagine this is a case of maintenance where we know a planned maintenance. We are trying to bring down one of the member. So we are stopping the group replication. Now if we do any transactions, they won't be applied on this member. Not just that, we even stop the MySQL. Now there is a change in the group. From 3 members initially, we are now at 2 members. So there is a change in the view. So the view gets propagated across the members. And this thing, previously it was 23, view ID is 23. Now there will be change in that as well. So we can see that. Okay. If you see here, the view ID changed for 24 because now the group, the other members of the group are made aware that one of the member has gone. That is from MySQL 2. Let me check from MySQL 3. From MySQL 3 also view ID changed. And this view change event also in fact gets propagated across the group. So now let's check the content of the table. So 4,300 odd records on MySQL 3 and the same records on MySQL 2 as well. Now let's do some transactions. From one of them we will do 100. This thing is as good as we are performing the transactions while the member 1 is down, because the group is still having the majority, and as long as the group is having majority, we can still perform the DMLs and reads. We did it like 100 transactions from this group member MySQL 3. We'll try to do different 200 transactions from this member. So now if you see the count, it has got 200 plus 100, 300. So 300 increased, 300 records increased, and 300 transactions are also done across the group. Those transactions happened while MySQL 1 was down. Now, once we bring up this member, we need to ensure that all those missing 300 transactions are applied on this member also. So replication group members show it is having only 2 members in online state and in primary role, since it is multi-primary mode. 2 members are 1 230 and 1 220. MySQL 2, 220 is MySQL 2 and 230 is MySQL 3. So let's check the same thing from the other member also, which is MySQL 2. The same thing, it shows 2 members are available and both of them are in online, and none of them say the third member is available. So now let's bring up the third member and let's get it into sync with the other members. But before that, I want to share some details. Okay, so in a group replication, there will be two types of networks associated with each member. Each member, the clients connect to it through the external network and does the DML or the read operations. There is also one internal network associated with each member that is used for the group replication. You see the line in the this color, this is used for group replication. Each member is in touch with other member all the time and it sends messages. So that messaging is happened over the internal network for group replication. Now in the case of distributed recovery, when this node goes down and when you are trying to bring it up, it acts as a client and connects to one of the existing members. It connects to this one or this one as a client, and when it is connecting as a client, the network is being shared by clients as well as for the distributed recovery also. But in case if you don't want that to happen, you can advertise alternative network that can be used by the members for distributed recovery. That is recommended. So let me show all the three details. I have connected to an existing member, and if you see show variables like host MySQL2. So the external clients connect over the host name MySQL2 and on the port 3306, and they perform their selects or the DMLs. Whereas this node, for the sake of group replication, you see this thing, this variable group replication local address. So this member is saying that the other members in the group can be in touch with this member through group replication on this IP address and on this port. This is from MySQL 2. If you see the same thing on MySQL 3, okay, you see this thing here, group replication local address. We are saying that the other members can be in touch with this member for the sake of group replication through this IP address and through this 33061. And if you want to use an alternate network for distributed recovery, you can make use of group replication advertise recovery endpoints. So if you give alternate endpoint, that would be used, but in our case we are just using the same network that is being used by clients, which is the hostname and the port. So that is one thing. Let me also show the host name for this thing where the clients connect, MySQL 3 and on port 3306. These are all the variables that influence the group replication. So if you see this thing, group replication GTID assignment block size 1 million. So each member is assigned a bunch of 1 million GTIDs. That's why you saw that you saw this thing, right? First 1 million is assigned to one member, and then from 1 million to 2 million is assigned to second member, and from 2 million to 3 million is assigned to another member. So each member is assigned a block of 1 million GTIDs. And if it's filled, it will get another block. These are all the parameters or the variables related to the SSL for the group. You see this thing, group replication, group name. What is the name of the group? And this thing is in the form of the UUID. And group replication, group seeds. So what are the seed nodes for this group? So we mentioned all of them are the seed nodes. And for the group replication, the port being used is 33061. Also, when the joining member tries to join the group or rejoin the group, it must authenticate itself with the group. For that, it needs to share the username and the password because it acts as a client now. So it needs to send the details and get itself authenticate with one of the members. For that, it can send the username in plain text format, but it can't send the password in plain text format, since the plugin that is being used by default in latest versions of MySQL is caching SHA2 password. So you can't send the password in plain text format for the case of distributed recovery. So you either need to rely on SSL for distributed recovery, or you need to make use of the RSA key pairs. So you need to make use of one of the things. So if you want to make use of the SSL for the case of distributed recovery, then you need to set this parameter. You see this thing, group replication recovery, use SSL. For the case of recovery, do we want to use the SSL? We have set this to off. Let's check the same thing from the other member also, MySQL2. Group replication recovery, use SSL. So out of the two options, we are not making use of the SSL to send the password encrypted to the other members. Then we have to make use of the RSA key pairs. And for that, by default, the joining member is able to fetch the public key from one of the donors and use that public key to encrypt the password. But for any reason, the joining member is unable to fetch the public key from the donors, then from the existing nodes, we have to get the public key from both the existing nodes, get the public key and write those public key details into a file on the failed node. And before you start the group replication, you set a variable saying that group replication now needs to make use of this file's public key to encrypt the password and send it to the existing members. Then the existing members, since they already have a private key with them, both of them will have a private key. It can make use of the private key to decrypt the password and then authenticate if this node is actually sending the character credentials to connect into the group or not. Once it authenticates, then it will be able to do the state transfer from its binary logs. It will be able to do the state transfer. So for that, we need to get the public key from both the nodes, node 1 and node 2, and write into a file. In this video, we wanted to imitate a scenario where joining member is unable to fetch the keys from the donors. So we copy them into a file on the joining member and refer to that file using group replication recovery public key path. Let's do that now. Okay, public key.pem, and let's go to the other node also, MySQL3. Okay, let's copy the content of the public key. That's from MySQL3. So from MySQL2, This is from MySQL to copy the public key. Now we will copy the public keys from both the nodes into a file in the failed node, which is MySQL1. Okay, I'm into the failed node. Currently the group replication is down on this node. I just put a file name and I want to copy the contents, the public key contents from the other two members. Now MySQL is actually still not up here. Let me bring it up now. Okay. You would be able to do the reads from this member, but the data would be stale. So the other members have 300 transaction additionally, 4602 here, whereas it is 4302 records here. Okay. So on MySQL2 and on MySQL3, we have additional records. So the state transfer should be done from one of these members to the MySQL1 now. And for this thing, to make use of those key pairs which we just copied, we need to set a variable. Set global replication recovery public key path. For the case of recovery, it should make use of this public key which is mentioned in this file. Now we can start the group replication, and as soon as we start the group replication, it makes use of this public key, encrypt the password, send it to one of these members, and then once the members validate the password is correct, then the state transfer would be initiated. We can even track the progress of the state transfer, and further there is an option for us. Okay, let me connect to MySQL1 on a different window so that I can do the tracking. I want to do the tracking of the recovery, how much is done and all that stuff. We can do the tracking of the distributed recovery with this table. As of now, we have not yet started the group replication. So let me go ahead and start the group replication. Okay, you see that group replication started, and since our thing was only 300 transactions, it completed in no time. Group replication recovery channel, the service started, and last apply transaction, it was applying this transaction at the time when we were checking, and it completed immediately because we just had 300 transactions and the data was very low. So now if we check from member 1 or MySQL1, it has got those pending transactions that were done on the group while this member was down. So we completed the distributed recovery using the RSA key pairs. I also want to show the log file from MySQL1. So this is my MySQL1. Okay, if you see here, So this member, as and when we started the group replication here, it set the super read only to on, so we will not be able to perform any DMLs on this node. And then it connected to the group and understood itself it is lagging behind, and it started a distributed recovery, incremental recovery from a group donor. Group membership changed to, and you see this thing here, the view changed 25, the change in the view, and then it connected to 192.168.1.220, which is MySQL 2 for the sake of state transfer. Till the time it rejoined back, it got all those transactions through the state transfer. Once the state transfer is done, this server was declared online again within the replication group. It is declared online once the state transfer is done, and it is ready to accept DMLs now. So we can see all those details here in the log file of the MySQL one. Let's also check the status of the replication group members. Okay, now it says all the 3 members are online and all of them are in primary role. That is from MySQL one. Let's check the same thing from MySQL 2 and also from MySQL 3. Let's also try to insert a few records now and see. I'm just trying to do 110 records inserted into the users table by calling this function. Okay, now let me check the GTID across all the members. Let me copy this thing into a notepad so it is easy for us to compare. So this is from MySQL 1. MySQL 2. And MySQL 3. So you see the GTID is 2181, 2181, and then for the second block it is 2336. It is the same thing across all the members, and for the third one it is 0419. So GTIDs are matching, so the data should be consistent across all the members of the group now. (4,712) records. The same thing across all the members. So in this way we did the distributed recovery of one of the member and got all the transactions that were done on the group while this member was down onto this member, and brought it in sync with the other members of the group. And that completes this video. Thank you for watching.